Everyone, welcome back to the workshop. And recently I've been taking a look at a lot of more portable lasers. A lot of people like to be able to up their sales at craft shows and events by being able to do customization of items on site. And so today we are looking at the Atomstack P1. This is a mini 5-watt blue diode laser, but they also have an optional IR module to come with it. As you can see, it is fully enclosed, which is great for engraving on site to have that safety factor. So I'm going to be taking a look at this as to what it can do, how well it performs with both the 5-watt blue diode as well as the 1.2-watt IR module. And we'll see if maybe this also might be something for someone looking for a small engraver, something just to kind of dabble with, get started with it. So if you're interested in this, want to find out more, stay tuned. I'm going to jump right into it. I am going to go a little more in depth in this video on some of the features and the software. So I will put some chapters down below. If you want to skip ahead to the testing and what I came up with as far as materials and what it would work with, check down in the description. You can jump right ahead to that. If you are new to using this laser, I do talk a little bit more about getting it installed and hooking up to your computer. So you might want to watch through the whole thing. Either way, appreciate you being here. Appreciate Atomstack sending this out for my review. They did not pay me for this. They just provided the equipment. And so with all that out of the way, let's get started and jump right into it. So let's take a quick look at what comes in the basic kit. You do have your primary laser here front and center, and there's no real assembly. It basically comes assembled as this. You will need to pull some foam parts out that protect it during shipping. If your module is not installed, you may have to slide that in, but we'll take a look at that in just a little bit. Along with it, it does have the standard USB as long as the USB-C connectors. This end goes into the laser, so not to worry, whichever computer you have, that'll connect up to it. And it does, of course, have the power cord and power supply. This is a 24 volt, 3 amp power supply, so roughly a 75 watt power supply. That will just plug into the side. Then we also have a nice instruction manual. This is in multiple languages of English, German, French, and Italian, and Spanish. So just some basic information on the operation of the laser, how to connect things up, and then also some laser module replacements. And then at the back, they even have some cleaning and maintenance tips as well. So decent manual, easy to follow along. Then there's just a few accessories. There's a small piece of MDF to do some initial testing. They have a lint-free cloth for cleaning, a couple of USB lockout keys. You'll need to plug this into the side of the laser. And then 4 little neodymium magnets. I'm not 100% sure what those are for, but they are included. Then if you do so choose, they do have an optional 1.2 watt IR laser module. This is fairly easy to add onto the laser. They have this kind of little cam lock system onto these dovetail slides. You will just slide the one in and out and then swap the cable. But again, we'll take a look at that in just a little bit. As I mentioned earlier, there's not a lot of assembly here, but there are a few things we need to look at on the outside of the laser and get connected. So starting up at the front, we do have our USB key. This is like a little interlock. This is one of the safety devices on this laser. Basically, it won't operate without it. So it's just like a little USB dongle. You need to plug it in. And when that is in, then the laser will operate. This is nice if you want to make sure that people can't use it when you're not around. For myself, I just leave them in there because I don't want to lose them. But nice little extra layer of safety if you need it. Our next port is going to be an accessory interface. It's similar to another USB port. So they do have like a rotary and a few other devices you can plug into this that will expand its capabilities. We're not going to be looking at any of that today though. There is a USB drive, so if you're running this through the app on mobile, you can pull up files off of that drive and then be able to run this without a computer attached to it. I'm doing the bulk of my operations using software that are connected to the computer. It does work with both the Atomstack Studio software as well as Lightburn. Then the next one is the USB cable. So as I mentioned earlier, we do have this cable with the dual heads that go to the computer. There's a USB port or USB-C port, and this will just plug into the back here and then allow you to work the device. You do need to run this way both with Atomstack Studio as well as Lightburn. However, if you're using the Lightburn or the Atomstack Studio app on mobile device, then you can actually work wirelessly to this. Then of course at the back we have our power. So our power brick is going to get plugged into here, and then our power switch in the back. Looking at the top of the laser, we have just a couple buttons here and a couple lights. There's a status light as far as it will be green or red if there's like an error or it's ready to go, Wi-Fi if it's connected to Wi-Fi. And then you have a frame and repeat button as well as a start pause button. On the back of the laser, there is just a placard and some warning information talking about the laser, as well as there is an exhaust port on this one. It is a small, a little bit under 2-inch fan. For this size enclosure, that's actually a perfect size for it. Doesn't need to be much bigger because there's not a whole lot of volume on the inside. So this will be able to be connected up to one of their air purifiers, or you could pipe it outside if needed. It is advisable to do that. If you're using this indoors, you're going to want to be able to capture that either through a smoke purifier or through a vent to the outside, which would be the preferable way. As I mentioned earlier, on the front 3 sides, we do have this kind of safety acrylic in these panels. The side 2 are fixed, but the front one is a door that opens up and allows you access into the laser. Now this latch does have a little metal plate here, and there is a magnet sensor inside here so that it can tell when the door is open or closed. Another one of the safety features that it's going to pause the job if you open the door, as to not endanger you from getting any laser radiation light. If you're using this on site in an event, that's a nice feature, that this is fully enclosed and people can see what the laser's doing. You can see what the laser's doing, but there's not a risk of them getting any danger from light exposure to that laser light. So bringing you in closer, we can open this up and you can kind of see on the inside there. We do have a bit of a gantry system here that the laser can move around on. We do have some linear rods that the module's riding on. So that is one maintenance point. You're going to need to keep those clean. And then on the sides, we do see we have limit switches, so this machine can home as well as detect when it bumps into the side to help protect it from jamming itself. And then at the bottom here, we do have a base plate. This can come out for a variety of reasons. This is how we would access the module. But on this plate, it does also show the working area of the 2 different modules. Because the placement of the module, there are different sizes, the actual emitter is a little bit offset. So this line off to the left side here, the solid line with the bigger lines on the bottom, that's your blue diode laser and the 455 nanometer wavelength. This hashed line over here, that's off to the right and just a little bit down, that's going to be your IR. It's a little unfortunate that they're not in the same position, because if you want to set up kind of a fixture or jig to be able to use one or the other, you're going to need to create that offset and work with it that way. But it's the best way for them to fit this into a compact format. Now to adjust the focus, there is I'm going to try to show you this best I can without getting my hands in the way. To adjust the focus, we do have this little knob here that flips down out of the way, and then we do have this focus bar, this little metal bar here that will touch off the material. So we want to put our material in our platform and our working area. We want to release this knob, so we're going to flip that down. That releases the module on the rails. We can bring it down to where this focus bar just touches off, and then we want to flip this back up, lock that in place, and then flip our bar out of the way. And now the beam should be focused on the top of our material. Now, if we need to service or swap out the module, it's fairly simple. We just need to push this out of the way a little bit. There's a lever down on the bottom here. We're going to slide this out of the way, and then this little platform will pop up and slide out. It's got a couple notches that hold it in place. Then we can tip the laser up on its side so that we can access everything. We're going to once again want to release the module lock screw by flipping that off to the side. This will allow us to slide it off the rails, and then there is the connector on the back. You want to try to grab it by the plastic plug, not the wires, and just pop it out of the connector as so. Again, you don't want to pull on the wires. There we go. And now the module is free, and so now you can get a better look at this. This is also something you want to look out for. There's the cover lens on the bottom here, and over time, since this doesn't have an air assist on there, there's definitely going to be some smoke and debris on there. As a matter of fact, there's a little bit on there from my tests already. You want to use a lint-free cloth or a lint-free swab, a little bit of pure alcohol. Just wipe that down, let it dry, and that will be part of your maintenance on this. Now to reinstall, we just simply need to get these rails lined up with these on here. You want to plug the module back in. Once again, we don't want to be pushing on the wires, so push on the plug till that snaps in, and then slide this up over those rails. Make sure the plug fits in there, and then you can lock this in place. So here it's locked in place, but it's pointed back, so I can just lift this up and bring it forward all the way around to the top, so that now I can bring this down, it releases it, and then bring it up to lock it in place. All right, let's talk software really briefly. I've loaded up the Atomstack Studio, and you can find this if you go to Atomstack's website and come over to software. It'll bring you to this page. They do have versions for Windows, Mac OS. They also have mobile versions for iOS and Android. You'll need to download those from the appropriate Play or Apple Store. And then this will allow you to work with this device for free. There's no cost to this. And you can get started working with images and importing vector graphics and parts and such. So it is nice that they offer a piece of software that will allow you to work with this at no additional cost. Now, I have Lightburn, and this does work with Lightburn. We'll look at that in just a minute. And it's my preferred method because I've been using it for years. But let's take a quick look at Atomstack Studio. Now, what I didn't mention earlier is this does come with a USB drive, and I've plugged it into my computer here. It does have a few files on here. They do have their manual, so if you accidentally lost yours, you can pull up this USB drive, and they do have a PDF version of the manual here that you can scroll through. Otherwise, they have a folder here, which is very useful, parameter table. So in here, they have both the 1.2 watt infrared laser and the 5 watt diode laser. They have tables that you can open up these, and they will list different sizes of, or different settings for different types of materials. So this is the 1.2, and it has, you know, brass, iron sheet, coated aluminum. And over here on the diode, we have like bamboo, beech, craft paper, and so on. And you can just reference their speed, power, any other settings that you need to for this. So it is really nice that they include that if you were using Lightburn. I believe in their software, they do have some preset parameters as well. Use these as baselines. They may be a little bit different for your material and your laser. Back here in Atomstack Studio, we're going to load it up, and it will connect via USB. Using the computer, you do need to use USB. You can't use Wi-Fi, but if you're using the mobile app, you can also do it over mobile. And you should see in there, if you come to the device manager for your computer, you'll see a USB serial CH340. Mine happens to be on COM6. Yours might be on something else. But that's how to see if the computer is seeing it, and then the computer or the software should see it. If you don't see that, you can go to this device or this page here from the Spark Fund. It's a site I trust. CH340 drivers are fairly generic. They're used in a lot of devices, and especially the GRail drivers, they use this. So you can download it here, and they have instructions on working with Windows 7 and 10, Mac OS, and whatnot. So if it's not detecting it and it does need these drivers, I'll have a link down below where you can find this page and get them installed for your device. But once that's there, you should be able to see up here, or you might need to come up here, click on the upper right, and you can switch the device. Here we can see I used to have the craft connected to it. If you need to add a device, you can come in here and it should auto-detect that. Otherwise, we are going to stick with the P1. You can also switch the mode from regular to cylindrical. They do have attachments for rotaries and such. You can make that change in here, and you can do some minor changes. They do have a safety feature for tilt detection. You can turn that on and off. Same thing with box door. That should be the front door. They have a sensor on there to kind of deactivate the device when the door is open. You can turn that off if you want, but I don't necessarily recommend it just from a safety standpoint. Otherwise, once we have our device connected, we can work around in here. One of the things you'll probably most likely do is you're going to want to import an image. So you can come over here to the image tab, and I just happen to have an image here in my pictures folder. It's just saying, do we want to adjust the size because it's large? So yeah, let's scale it down, and there you see a
photo, yours truly, we can adjust the size of this down. And then we can play around with the mode. So the mode up here, that's going to be the dithering and how it does the dot pattern. Jarvis and Atkinson are ones I use quite often. So I would just stick with the default. You can play around with these. The vague is kind of a blur effect. You can play around a little bit with brightness and contrast. Reverse color would be if you need to engrave on a dark item that's going to turn white, you'd want to invert it or reverse it. So then our other settings over here are going to be off to the side. So it's recognizing it here as a bitmap image, so it's going to do an image mode. If we had other items here, such as if we wanted to draw a rectangle around this, we could drop that in there. And now you'll see we have an additional layer. This one is set to be a line, so we could then cut it out, or you could do a fill and it would just do a completely black out of that. From there, it's going to show kind of the default power and speed, but we can come in here where it has manual parameters and we can pick materials. So for example, if we're doing this on wood, we might pick basswood, and they are going to show kind of a settings that they recommend for that. So 8080 for the image layer. And then if we change this to cut, it would say, okay, power 80 and speed 120. So you can play around with their presets, or you can create your own, or you can just manually change these yourselves, tweak them by numbers or the sliders. Once we have that set up and going, we could then use the controls here to get it positioned on our material. It's currently running in absolute coordinates, but you can switch that from current position to user origin as needed. I like working in absolute coordinates, so you just need to make sure you home the machine first. But that's kind of the overview in Atomstack Studio. I am not well-versed in this software by any means, but playing around with it a little bit to get used to it and be able to show you that you don't need to buy Lightburn just to get started with this. But let's go ahead and go take a look at things in Lightburn. Okay, so I've got Lightburn loaded up. It's defaulted to one of my other lasers. One thing on this USB drive that I showed you earlier, if we go back to the root, they have a device file for the P1 for Lightburn, which is very handy. So once we have confirmed that it is showing up here in Device Manager and it's on COM port 6, what you want to do is click on Devices, and instead of Find My Laser, just go to Import, browse to your USB drive, select that device, hit Open, and that should, down here at the bottom, add the machine for you. Now I've already added it, so we don't need this second one. I'm going to go ahead and delete this. That's a super easy way to get this added into Lightburn. So for our first project, I always recommend doing a material test, but we're going to go off of their parameters. So if we jump back over here, we can look at what they have in here for the 5-watt diode. They have a variety of different materials in here: plastic, rubber, denim, ceramic tile. So they have a few wooden ones. I'm going to be using a piece of Baltic birch plywood here. We're going to go ahead and set this into the laser. And I'm going to center it kind of in this white box, not the dashed line, but the white one, the solid white one, because that is what is on our, we've got the 5-watt blue diode going. So jumping back into Lightburn now. So first thing I'm going to do is home the machine. Then I'm going to grab our movement tool, click over in the center just to bring it above our material. And this is where I need to go ahead and focus it. So I'm going to drop down that lever, touch that off the surface, tighten up the knob, and flip that back up. So now we know that that is in focus on the top material. I will rehome this. And the other thing that you want to check here is I'm running in absolute coordinates. You can change this to current position and then just physically move the laser, but it's not as easy to see where the module, the emitter output is on the module with this. So I like running in current position, but there are a few cases where you might not want to do that. So we have that hooked up. And the other thing I do like to double check is here in device settings in the edit menu, come down and make sure that enable laser fire button is on, laser on when framing. We'll drop that to 0.5%. What this will do is really low power. It will kind of highlight on the piece of material where the laser is going to frame to its extent. So I'm going to click on our words and we're just going to do a quick test and bring this again to the center. Let's scale it down. We really don't need this to be too big. I'm going to come over to cuts and layers, and It's on the black layer. I usually use that for line. I use blue for fill and engrave. And here we want to go back and reference our engraving speeds. So here on basswood, which is pretty close, or I guess either one, yellow peach wood, pine. Yeah, let's go with pines, might be closest to birch. So we'll go with 5,000 and 80%. And then you want to note the line interval is 0.08. We're going to come over here. We're going to change our settings. So we want this to be 5,000, 80%, and we need to bump this up to 0.08. Single pass, everything looks good there. Now we're going to close this because the laser module is going to want to fire. And make sure we're in absolute coordinates again, and then we are going to hit the frame button. We'll see it's going to draw a quick outline there. We're at 5,080, and let's go ahead and send this job. So the laser is working. It's in bidirectional mode, which is nice. That'll be done faster. And we are getting a decent engrave on that. The fan is working right now. I just have it exhausting out. I have printed an adapter that I can run this into the larger smoke purifier. But being that's such a small outlet, I can't really hook it into my normal exhaust system. But this is just about done. Looks like it's going to take roughly about 40 to 42 seconds to do this quick little test. All right, that test is complete. Open this up. So there you see we have a nice little engraved test, and worked out pretty well. Their test file or their test settings, even though they didn't have necessarily Baltic birch, the pine was pretty close to us, looked pretty good. But let's just zoom back out. I'm going to show you all the other tests and materials I worked with. Give you some power and speed settings to get you started. Using the material test tool in Lightburn, I was able to run through a few just sample tests on some of the material I would use. I don't think this is going to be great for cutting the thicker, heavier Baltic birch, but I did run an engraved test on Baltic birch, and this is where it came out. I ran it from 1,000 millimeters a minute on up to the top speed of 10,000 millimeters a minute, and then went from 10 to 100% power. And you can see the gradient there down at the bottom. The 1 and 2,000 are really kind of getting blown out. A lot of vaporization and smoke debris on the outside. But as we start getting into 3,000 and 4,000, that evens out. So looking at getting a dark engraving, we're going to want to slow it down into that 4,000 to 6,000 range on this material to be able to get a quality dark engraving, but still have a decent gradient down to the bottom. On these wooden materials like this, in a vector engrave, we're probably going to be sticking around the 5,000 to 6,000 millimeters a minute, maybe a little bit under to be doing that work. So with that, went ahead and grabbed a photo, and here we have, I've used this in the past. It's kind of an AI kitten sitting on kind of a wooden floor, and ran this at 4,000 millimeters a minute, 100% power. Did a 0.080 millimeter line interval, and this is Atkinson dithering. This is a raster engrave, and this took about 23 minutes. Now this is roughly a 3.5 inch square piece of material using the bulk of it. So that is not quite maxing this out. The working area of this is just over 4 inches square, I think 4.1 inches square, 110 millimeters, but using the bulk of it. And like I say, 23 minutes, the quality is really nice. And that's one thing you're going to find on these lower power diodes is that they have a finer spot size. The quality is going to be up there. However, you're going to make up for that in the speed of the operation. So pretty happy with how that came out and working on, this is again, some Baltic birch plywood. So now keeping on with the wooden theme, but mixing it up to a different material, I did grab one of these pine coasters I've gotten in bulk off of Amazon. And this time we went for more of a vector engrave. This is just a SVG file of like a tree of life kind of situation here. And again, this is a 4-inch coaster, so we're using the majority of it. Of course, we have a bit of a border there. But the settings for this, I ran this at 5,000 millimeters a minute, 80% power. Bumped it up to a 0.09 line interval, 0.09 millimeter, and still looking good. I'm not seeing any gaps there, so that line interval, depending on your material, you might be able to play with. And this took just under 16 minutes to complete. So definitely doable, not terribly time consuming, but not necessarily as fast as some of the more expensive lasers out there.
But again, this is a budget laser, the base model coming in around $250 to $300 at this time, a lot cheaper than some of your Galvo diodes out there. Now, being a 5-watt diode laser, its cutting capabilities are going to be a bit limited and or slow, but I did want to test that out. Now, it only has that flat base plate, and anytime you're cutting and doing through cuts, you kind of want to protect both your spoil board as well as provide some airflow. They didn't provide anything with that, but I did have this kind of knife plate that I have from some of my other lasers there, and you'll just see it has some ridges there that allow airflow underneath. So I did use this for these cut tests. Just note that this isn't included. It would be great if they had an option or could include something like this just in case you want to do cutting, but that's not specifically what this laser is geared towards, but I'm going to show you what it can do. So I have some 1/8 inch solid basswood. This isn't plywood, it is solid wood, but basswood is very kind of a consistent, lightweight grain, lightweight hardwood. And so this is kind of optimal settings for this. You can get basswood at a lot of craft stores or online in various thicknesses from I think a 32nd on up to a 1/4 inch or more. But we're using some 1/8 inch here. So I started out with these are single passes and went from 150 to 200 in our speed, that's millimeters per minute, and then went from 80, 90, and 100% power. Blew through all of those, which I wasn't sure it was going to do that, but impressed with that. So went ahead and bumped it up from 250 to 300, and there you see we're starting to get our drop off there again at 80, 90, and 100%. So even at 260 and 270, 100%, they were kind of popping out. But as always with these tests when cutting, I don't like to hit the exact maximum. You never know where you're going to run into imperfection in the material, so I always back it off. So I feel it's safe to say around 225 to 250 millimeters a minute, 100% power, single pass on 1/8 inch basswood, is we are going to be able to do some cutting with this device. So with that in mind, I did go ahead and cut out some small earrings. And they did do pretty well. Now, one side is going to be a little bit cleaner than the other just to the nature of the cutting and how that has to deal with some smoke and vaporization. And again, I was using that little cutting panel, which helps keep the bottom edge cleaner. But these did come out well. Everything dropped out, even those tiny spots up in the middle there. They dropped out okay. So definitely doable. Each of these took about, I want to say 3 minutes to cut out all the inner parts and the outer parts. So roughly 5 to 6 minutes if you were to set these up as a pair in your laser. Not too bad. Again, not super fast. There are faster ways to do it, but when you're talking about intricate details such as this, you don't want to blast it out with as much power and speed because you're going to get even worse looking edges than this. I had some 1/8 inch cedar laying around, so I thought I'd play around again with this, and if I can get this to focus on here, these are just some little cat heads, and there is, technically these could be earrings, there is this tiny little, there we go, get that focus, tiny little hook loop at the top there, but did cut these out. Now I did have to up this to about 3 passes to get this to cut through. The cedar just being a little more inconsistent, a little bit tougher than that basswood. So these being about 3/4 of an inch to an inch, about an inch wide, 3/4 tall. Again, about 3 to 4 minutes a piece. Not going to win any speed races, but also that's not terrible. You could definitely cut some of these out on site, show people, get them interested in what you're doing. Being that this is a low power laser and kind of aimed at beginners, wanted to play around with a little bit of craft paper. So started out with this, just kind of this brown, it's I don't know the specific weight of this, but it is kind of a craft paper, a little more durable. It's definitely more than your writing paper. Did this design, it's a little campfire engraving, trees and mountains in the background and a heart shape cut out. And so the engrave, I was using 7,500 millimeters a minute at 80% power. The cutout was 650 millimeters a minute at 90% power. And this whole thing just took about 3 to 4 minutes to do, or sorry, 6 minutes overall to do this. It was about 4 to 5 minutes to do the engraving and then just a minute and a half or so to do the cutout, and worked pretty well. So knowing that diode lasers sometimes struggle with different colors, also did this in red, similar tagboard stuff, and also kind of wanted to show the detail it could do. So you've seen those branches and the nest kind of things down here. Cut all that out really well. This was done at 650 millimeters a minute, 90% power, and the whole thing took 2.5 minutes to do. This is about 4 inches, just under 4 inches tall, and about 2.25 inches wide. So you definitely use this for doing some craft paper work, making some custom invitations, adding things to cards and such. One of the more popular things that people do with their lasers is custom coasters and of course slate. And so went ahead and ran this kind of Celtic circle, again, trying to maximize this. This is a 4-inch slate tile. And so we tried to maximize the size of the design. This is just a vector engrave. And we went at 6,000 millimeters a minute, 80% power. I believe these were the recommended settings within that the parameters file. 0.080 line interval, and this took just under 15 minutes to complete, but it came out pretty well and looking pretty nice. Now, this being a optional IR laser as well, if you're wanting to play around with the IR, you can on this, but you gotta remember it's got a finer spot size, so it's gonna take a finer line interval, it's gonna increase the time, but you can get different shades, maybe a little more brilliant white, although this one came out pretty nice. You can sometimes get a slightly more brilliant white out of the IR module, but at being a much tighter spot size, it's going to take a lot longer. This one, again, saying 15 minutes, not bad. Definitely there are other lasers that can do this faster, but at a $250 to $300 laser, definitely an option. Another fun thing to play with is synthetic leathers. And so I have here just a small little logo. It's my logo there. This is on some leatherette from Great Carve. It's got a fabric backer, and so it's a little bit thinner than, say, your some of your other brands that are a little bit thicker and such. But this stuff worked out pretty well. The engrave is done at 8,000 millimeters a minute, 70% power. In the cut, 500 millimeters a minute, 85% power. The whole thing took 3 minutes, 21 seconds. And this is, maybe an 1.25 inches, 1.5 inches tall and wide, so not terribly big, but doable. And actually the detail on this for the size is actually really nice. I don't know if you can see the stitching on there, but even those came out very nice. So one of the nice things about the 5-watt laser, very nice, solid detail, fine details possible with this. So we also can do anodized aluminum even with the blue diode laser. So grabbed a couple blanks here. This is just a dog tag, and went ahead and ran that. Used 1,000 millimeters a minute, 80% power, and a 0.080 millimeter line interval. That came out pretty well, fairly clean. This did take 4 minutes and about 10 seconds to complete, using, I would say, maybe half of that. So if you're wanting to do some pet tags or whatnot, again, this is doable. Probably gonna take you around 4 to 5 minutes a piece to do, so not as fast as the galvos, but if you're at an event and wanting to be doing some custom engraving, that's not too bad of a time to run that. Not only that, we can also do image engravings. So again, using this time a purple dog tag, dropped Clack's head in there. If you're not familiar with David over the Clack Shack, you could check him out. We do live streams on Sunday nights where we help people out with lasers and answer questions and talk about new things such as this. But this filled out the dog tag much more. Ran this at 0.070 line interval, 0.070 millimeter line interval, 1,000 millimeters a minute, 80% power. And this one did take about 10 minutes to complete. So again, not a speed demon, but definitely doable for working with anodized aluminum, and especially in these dog tags. That's a fun thing to do at events. All right, so another fun thing I've done, especially with the 5 watts in the past, is painted ceramic tiles. So here is a AI Wolf design in kind of a circular design. So this is taking up the better part of the 4-inch tile. This was spray painted with some flat black spray paint, let it dry, and then just engraved. Did it at 6,000 millimeters a minute, 80% power, 318 DPI, so right around that 0.080 line interval. And this took about 19.5 minutes, a little under 20 minutes. Like I say, it's filling up a lot of the area that the laser could work with, but came out very well. The detail on that one is very nice. A lot of detail coming out in the various aspects of that. So again, when you get into this 5-watt laser, it's not going to be a speed demon, but you are going to get a lot of detail. And another fun project you can do with that is painted tiles. You could do multi-layer tiles. Eventually that might get a little thick for this, but you could add multiple colors and adjust your power to get deeper or shallower and have some fun with that. So the last test I did with the blue diode laser was some acrylic. This is black cast acrylic, and went ahead and cut out a small logo, cut and engrave a small logo. Now, this was using their default settings. It is there, but it's not as brilliant, but it was able to cut this out. So this is a little under an eighth. So the power settings used on this were 5,000 millimeters a minute and 80% power for the engrave. And the cut was 175 millimeters a minute, 100% power and 3 passes, which it did get through this without any issue. But the engraving on it is a little muted, unfortunately. However, IR modules do very well in engraving black acrylic, so I ran that as well. And here you can see that it's coming out very brilliantly, very nice look, very high contrast. This was done at 10,000 millimeters a minute, 40% power. Only took a minute and a half to do that. However, the IR module is not going to really cut out the acrylic. This is where it'd be nice that if the two modules were lined up to where you could leave it in place, maybe swap out the module, and then cut it out with the blue diode, that'd be nice. Unfortunately, it's going to take some math and some offsetting to where you could risk getting that separate. So possibly cutting out your blanks first, setting up a jig, and then engraving them after with the blue or with the IR module would be the way to go. So for the rest of these tests, I did swap out for the IR module. Now this is an optional add-on. You can either buy it later or you can get it bundled. And so if you're wanting to play around with some metal items, you may want to consider this. It is just a 1.2 watt IR, but it does have a very fine spot size. A lot of these tests we had to run down to 0.010 millimeter line interval. So it's capable of a lot of detail, but it's also going to take a lot of time at that focal spot size. So we dropped this into the laser and then started running some tests. I started out with the anodized aluminum plate, and here you can see the power and speed test actually kind of fairly consistent throughout it all. I ran it from 7,000 on up to 10,000 millimeters a minute, so in the upper speed ranges. We were running at that interval of 0.010 millimeters, and then I ran it from 50 to 100% power. And that looked pretty good. So for most of these, you can get a little bit of variation in them, but looking good at 10,000 millimeters a minute and 50% power, getting a fairly brilliant white, and not having to push it at the full power for this. So with that, I went ahead and ran a test, dropped in Star Wars Grogu within front of the Mandalorian helmet, ran this at 10,000 millimeters a minute, dropped it to about 70% power. Just want to make sure that in some of the lower areas we still got a bit of a gradient. And then I did bump the line interval up to 0.025 millimeter to see if we could get away with that. But as you can kind of see, there is a little bit of banding in there. So I think that's pushing beyond it. We should have probably stuck at the 0.010 interval, and it would have come out a little bit cleaner. So with that, another thing that works well is stainless steel. So again, I set up a speed and power test using stainless steel cards. This is going from 1,000 on up to 4,000 millimeters a minute, and then 10 to 100% power. We do have a bit of a gradient. It's a little bit lighter up here, definitely darker down there. And I did have to kind of just clean this off a little bit. There's a little bit of a burn, and it's dark, but it's not like a black. It's kind of a brown. You'll get that a lot with these, depending on your stainless steel and your laser. It's not always going to be a super dark engrave, but this is without any treatment. This is just the capabilities of stainless steel. And then with that, I also ran an interval test from 0.010 up to 0.050. And you kind of see it gets darker to lighter. If you put it really close, you start seeing a little bit of a gaps. So you could run maybe a little bit less of a line interval and be okay with a lighter color. And so I did that, and this was the result of my logo on here. So this was run at 2,000 millimeters a minute, 100% power, and a 0.03 millimeter line interval, and did it okay. But that did still take, for about half this card, about 25 minutes to complete. So I wanted to really push it, and took our wolf image we did earlier on that tile, put it onto this stainless steel card, and put our settings at 2,000 millimeters a minute, 100% power, Atkinson, and then dropped it back down to the 0.010 millimeter line interval. And didn't get the banding that we got on the Grogu. Everything looks pretty good. Fairly dark up top, and we've got kind of the color variation as far as, well, the shading variation down at the bottom. But this did take an hour and 30 minutes to complete due to that fine spot size. And then took a stainless steel dog tag and took an image. This is an eagle. This is one of those things that's going to depend on the angle you look at it, but trying to get it in a good spot there, you can kind of see. We ran this at 3,500 millimeters a minute, 80% max power, with a threshold dithering and a 0.010 millimeter line interval. This did take about 14 minutes but came out pretty well. The quality is pretty decent. So again, something you could do. It's going to be a little bit faster using the blue diode, a little bit less detail, and the anodized aluminum tags. But if you want to play around with stainless steel, get some images, you definitely can, and that's where you're going to get a lot more detail. All right, so one more thing I want to show is an example how you might set this up at an event, especially if you're outdoors, you don't have access to shore power. Having a portable battery unit is really nice, in that the fact you can run this out in a field at often farmers markets and such, or in parking lots and just open areas. So I've got this hooked up. I have just the laser plugged into it. Now, taking in mind, whatever laptop you have is also going to possibly add to that drain on this. But we're going to just kind of take a look at the wattage and overall draw on this, give you an idea what to expect out of one of these. So I've set up a job. It's going to do some engraving, and then it's just going to jump it up to 100% power to do a cut. That should give us a rough idea of where this is going to peak out while running. So let's get that job running. We will take a look at the power draw. All right, so just doing the engrave, and we're about 80% power and 5,000 millimeters a minute. The fan on the back of that is running. We're only pulling about 20 watts out of this. So based on this one, we're going to be running for 43 hours just at those power settings. That's pretty good, and that would definitely last a full day or two. Obviously, if you're doing other things, adding your phone or your laptop to it, that may add to it as well. But once this gets done with that, we're going to check the cut, as that's going to be a more consistent power. It's going to be a high power that should kind of max out what we're going to be running with this. All right, our cut is running now. It is jumping up to 41 watts. So that's cutting it down to 23 hours. Still plenty of time on this. This is I think a 1200 watt unit, and I believe around 500 watt hour of battery storage on there. So that'll give you a rough estimate of what to expect out of average. You're going to want to take a look at your overall capacity of your battery, as well as then the power needs of anything else you might add on to this. So that's about all the tests I'm going to do on this laser. I hope that gave you a pretty good overview of its capabilities, maybe some of its limitations, and whether it might work for you, whether it's your first laser that you're getting started, or if you're looking at something to be a little more portable with, take to events and be able to do some on-site engraving. It does have some limitations as far as speed when you compare it to some of the more portable galvo styles, but that price factor, you want just the base model with that 5-watt blue diode laser, you're under $300 at the time of this video. That's a pretty good deal compared to the cost of those others. Are going to be at least double that. So it's a minimal investment to be able to allow you on-site engravings, which is a good way to really bump up your sales at events. If you do have any questions or comments, please go ahead and leave those down below. I do try to get back to those in a very timely manner and want to assist you if I can. And just tell me what you thought. Do you think this might be something that you would use as a first-time laser, or as something that you might take to events, or maybe in some other fashion? If you are interested in this laser, you haven't purchased it yet, I will have links down below where you can purchase this using my affiliate link. That does go and give me a small commission and tells Atomstack you appreciated my information and it was helpful in your purchase. So I appreciate you using that if you haven't purchased one yet and you're thinking about it. But as always, no pressure, just happy to give this information to you, make you a more informed consumer of your purchases. Anyway, I could go on for a while. I'm going to wrap it up now, but thanks again for watching this. I hope it was informative, but I hope most importantly you can get out in your workshop and make something too. We'll catch you next time.